Alright, section 2, finding the limit at a point. So in this section, it's basically just like it says, limits at points. 1 and 2-sided limits means for just a normal one-sided limit, we're just finding the limit at 1. So the limit as we approach from both sides at 1. If we're looking for a one-sided limit, none of those actually appear in this problem. Those would look like, hey, the limit as x approaches 1 from the positive side. From the positive side means from the bigger numbers. So that would be coming this direction. Whereas if we did the limit as x approaches 1 from the negative side, we'd be going from the negative side towards 1. So that often confuses people because like this technically is going in the negative direction, but we're coming from the positive side. It's like wind directions where it's like, hey, it's going south, southwest, and whatever. All right, so to actually solve this problem, first thing to do is to just plug in the value and see if it works, because a lot of limits are easy if you can just plug in the value. So we plug in 1, and we get 1 minus 1, and I guess we got to keep the absolute values around, over 1 plus 1 is 2. That's 0 over 2. That's 0. It doesn't matter that there's an absolute value there. The absolute value of 0 is 0. And then it's plus 2. Turns out this is a really easy limit. This goes away. It's 2. Hooray. We did it. So which means the limit coming from the positive side would be 2, and the limit from the negative side would also be 2 because they match. If these were different, we wouldn't have a limit for the total problem. It's kind of the big idea. All right, let's move on to our second problem here, which will be a little more involved. Okay, our limit as we approach negative 1. Negative 1 falls in the interval x is less than 0, so we're going to use this, and negative 13 is the value for all x values that are less than 0, so it's negative 13. That was pretty easy. All right, second problem. X as x approaches 5. All right, 5 is the intersection between these two. Now this is a wonky problem, and I should probably edit this. It can't be equal to both values. That's bad. So I'm going to make this one like this. And I'll update this online. So now let's plug in 5, and we get, alright, so on this side we get 5. On this side, this thing would be approaching negative 25 if we plugged in 5. So these don't match at all. Like our limit from the bigger side is negative 25. So the limit as x approaches 5 from the positive side is negative 25, and the limit as x approaches 5 from the negative side of f of x is 5. So these don't match at all, and that's why the answer down below is undefined, because it is undefined. They don't match. That means this is no good. All right, now it says the limit at 0. So it's another place where we have an intersection. Here I didn't make that mistake, and we have less than or equal to here and a less than there. So that's totally peachy. All right, so if we plug into 0 here, we get negative 13 coming from the negative side. So limit as x approaches 0 from the negative side of f of x. And if we plug in 0 into this function, we get 0 as the limit approaches 0 from the positive side of f of x. And those also don't match, and that's why this one is undefined. Now, these aren't the only kinds of problems in this section. I just did a few representative examples. These are like the really easy kind, where it just kind of like works out. This guy's also kind of easy. These are kind of the like medium kind, where it's very obvious that they don't match up. There are harder cases, and if you want to find more examples, that's why I linked to problems like these on my site. 17 Calculus is a site where another skilled video maker called Patrick JMT, makes a lot of really great videos. There are example problems on there. And if you want more support, again, the problems on our quiz are not going to be exactly like this. They could be like this. They could be something more like the problems on these sites. So if you want to fully prepare, I would recommend looking at a few more different types of problems. But that's it for limits.